Week 3, homework problem 6. This problem has got a roller on a set of ramps where it's rolled down into a location where it can't escape. It's at its lowest possible point. For this type of problem, some assumptions are required, namely that the roller is perfectly round and that it's infinitely hard so that it only contacts the ramps in a single place. The same would be required of the ramps. The ramps would have to be perfectly linear and perfectly hard so that, again, we only get one single point of contact. That point of contact is called a point of tangency. And at the point of contact, there is a normal force developed, and by definition, because it's only one point of contact, this normal force is perpendicular to the face of the contact. And so I'm going to label these two normal forces, and I will call this N1 for normal force 1, and this is N2 for normal force 2. And normal is just a term that's used in physics to mean kind of a reaction that is perpendicular to a surface. So if you stand on the ground provides a normal force. It is an equal and opposite reaction to your weight. Now, if I think about this triangle here, well, the angle we've already stated by definition in this corner is 90 degrees. If this corner is 30 degrees, then this remaining corner here has got to be 60 degrees. And same thing here. I've defined this corner as 90 degrees. The problem gave us this corner as 40 degrees. This angle here has to be 50 degrees. And that's just a basic property of triangles. So that if I were to redraw these two normal force vectors, they would look something like this. The one on the left has a magnitude of N1. This included angle, it's 50 degrees, and this vector is pushing to the right and upward, and I'm going to call the rightward push x1 and the upward push y1. And the vector on this side pushes up and to the left. It has a magnitude of N2. It's got an upward component that I'm going to call y2, and a leftward component that I'm going to call x2. And again, this included angle we've already determined is 60 degrees. And by definition, as will be the case of all of these problems, the y vector component and the x vector components are perpendicular. Now let's think about some of the things we know. Well, if this is going to be in static equilibrium, the sum of all of the forces in the x direction must add to 0, which means that the magnitude of x1, and I'm going to put this within an absolute value sign so we don't need to worry about the sign of x1 and x2, these two magnitudes have to be equal. What else do we know? Well, we know the sum of all of the forces in the y direction must be 0. So we have a weight of 150, which would be expressed as a negative number. So what I can say about the y's is y1 plus y2 must add to 150 pounds. Now it's a matter of doing some mathematical parlor tricks to get this down to one variable, because we have too many things that we don't know. So let's think about what else we could know just from basic trigonometric identities. If I look at this left side triangle, well, I know the cosine of 50 degrees relates the opposite, the adjacent and the hypotenuse equals x1 over n1. And on this side, I know the cosine of 60 degrees relates x2 to n2. But what do we know about x1 and x2? Well, by definition, their magnitudes are equal. So let's rearrange this. So I'm going to multiply both sides of this formula by n1, and I get n1 times cosine 50 equals x1. In this formula here, I'm going to strike x2, and in its place I'm going to put x1. And I can do that because we've already stated at the outset that they have to be equal. And then I'm going to multiply both sides of this formula by n2. So I'm going to rearrange things a little bit. I'm going to put the x1 on the left side, and I'm going to say equals n2 times cosine 60. But notice what we have here now. We have two expressions that are equal to x1, so that would mean they are equal to each other. Well, let's just cut out the middleman. So if I rewrite this, now I've got two expressions that have no x term in them. They only have n terms in them. So n1 times cosine of 50 equals n2 times cosine of 60. Now my intent here is to relate n1 and n2. So what I'll do is I'll just simply divide both sides by cosine 60. So n1 times cosine of 50 over cosine of 60 equals n2. So that's one of the important relationships that we need to untangle this mathematical mess here. Now, the other thing we should think about are the sine functions. So let's think about sine. So what do we know? Well, sine of 50, I'm looking at the left side now, relates y1 to n1, and sine of 60 relates y2 to n2. But we can take this a little further. If I multiply both of these by the n variable, I get n1 times the sine of 50 equals y1, and I get n2 times the sine of 60 equals y2. But what do we know about y1 and y2? Well, we know they add to 150, so I could rewrite this n1 times the sine of 50 plus n2 times the sine of 60 equals 150. Now here's where the mathematical parlor trick comes in. I have two variables here. I have n1 and n2, and you can't solve for two variables, so you have to find a way to wash one of them out. Well, is there a way I could get rid of n2 and in its place put some function of n1? Well, the answer is sure. We've already developed that right over here. So I'm going to take n2 out of this formula, and I'm going to put this stuff in its place. So let's take a look. So again, it's n1 times sine of 50 plus, now in place of n2, I'm going to put all of this stuff. n1 times the cosine of 50 over the cosine of 60 times the sine of 60, and that's going to equal that 150. But I can simplify this further. You'll notice now that I'm down to just one variable. n1 is the only variable. But look at this. I have sine 60 over cosine 60. Well, let's think for a minute about what that means. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. So what I'm trying to do here is I'm trying to take the opposite over the hypotenuse over the adjacent over the hypotenuse. But that is equivalent to opposite over hypotenuse times hypotenuse over adjacent. In other words, dividing by something is equivalent to multiplying by its reciprocal. Well, do you see anything that we can cancel out here? Well, sure, we've got a hypotenuse term, top and bottom. So I'm going to strike both of these, and I'm going to find out that sine divided by cosine is equivalent to the ratio of opposite to adjacent, but that function is just simply the tangent. So I can rewrite this again in simpler terms. N1 times sine of 50 plus N1 times, now this is going to go away and get replaced by the tangent function. So it's just cosine of 50 times tangent 60 equals 150. Now it's just a matter of algebraic manipulation. I'm just going to pull the n1s out. So n1 times sine of 50 plus cosine of 50 tangent of 50 equals 150. So basically, if I take 150 and I divide it by all of this junk, I'll be able to get the value for n1. So probably the easiest place to start with this in your calculator is to work with this most complex term, this cosine 50 tangent 50. So I'm going to say 50 cosine, and then I'm going to multiply it by, I'm sorry, it's tangent 60 if I look back. 60 tangent. Now, I'm not done. The calculator's showing me that it's ready to execute this calculation. This number here is the tangent of 60, so I'm going to hit equals. That's the value of cosine 50 times tangent 50. To that, I'm going to add the sine of 50. So again, that's the value of the sine of 50. When I hit equals, that will give me the value of the sum. And so what we find is that all of this stuff inside the parentheses here is equal to about 1.9. Now, what do I want to do? I want to divide 150 by that. Well, rather than writing this all down, what I'll do is I'll use the 1 over function, the reciprocal function, and now I'll multiply by 150. And what we find is that normal force 1 is about 79.8 pounds.
All right.
Okay, so this right here, about 79.8 pounds. Now, how is normal force 1 and normal force 2 related? Well, they're related by the cosine of 50 divided by the cosine of 60. So, very simply, what we can do is say 50 cosine divided by 60 cosine. Hit the equals key. There's your quantity. That number times n1 will give you n2. So times 79.8. And n2 is going to give you 102.6. If we check the answers that are given by the text, we see that we get the correct answers. So that was somewhat computationally intense. There was nothing that was profoundly difficult to understand there. It was just took a lot of computation and some mathematical trickery, and that's maybe the thing to take away from this problem, is that you'll never see anything really more complex than this when you encounter these types of problems. It's just a matter of being clever enough to figure out which mathematical tricks to use to untie the knot, so to speak.